All right, so your homework for tonight, it's write the equation of parabola in standard form and graph. You're given 6 different equations. We have this one starting with y squared, then this one starting with x squared, then this one with y squared, x squared, y squared. So try to give you an even amount, 3 of each. So today I'm going to show you the last process of writing a quadratic equation in standard form. We already covered a bunch of stuff, and I'm going to show you right now as soon as you're done copying that. Everybody done? Yeah. All right. Oh, out of request, they want me to go over number 6 on the warm-up. Let me go back to number 6. All right, so by now, guys, these with radicals, you should be able to do, but here goes the process one more time. When you get to these that is not a perfect square number, what does that mean, Mr. Q? That it's not one of these. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, 64, 81, 100, 121, and so on and so forth. And then you take the number 75 and you ask yourself, between which of those perfect square numbers can 75 fit? If it's in between where? These two. Because they would go after 64 but before 81. So that's 64 and 81. But they want the square root of 75. So if they want the square root of 75, that means we need to find the square root of 64 and 81. So it has to be between the square root of these two. That's why I only need to take the square root of the smallest one. That's why this is going to be 8 point something. How do we find that something? You take the middle number, subtract from the small number. That gives me 11. And then the large number, subtract from the small number, and that is 17. From there, you just make that into a division and divide to get your decimal. Does not fit in there, add a decimal and a 0. If it's in there, six. 102, subtract, that's 8. Add another 0. It's in there. 4. That's 68. Subtract, that's 12. And I'll stop right there. This stays a 6, so this is 8.6. Okay? Yes, Mr. Q. All right, good. So, once again, the home plate 6 problems only. So, our objective for today, I can write and graph a quadratic equation of a parabola. Bless you. I can write and graph a quadratic equation of a parabola. Do we need a Freyer model? No. If I was asking for the definition of a parabola, what is the key word? Key word. Equidistant. Equidistant what? Points? From where? From a line and a point, known as the directrix and the focus. Okay? The non-example, hashtag, and so on and so forth. So here goes a recap of everything we've seen up to right now with parabolas. Here we go. Look up, please. And writing equations. We said, all right, guys, we're starting with writing parabolas and their standard form of equation. And it's going to look like this. Itty-bitty equation. Remember that? And I said, the only thing we need to put in some work. And here's the work that we did. Boom. So we did the deriving the quadratic formula. There it is. And I said, however, we're only going to write these 2 equations to start with. And I said, to graph, I'm going to give you that the parabolas are crossing through the point of origin. What does that mean, Mr. Q? That they need to cross through 0, 0. So anytime we came up with the equation, it either went like this through the point of origin, or like this, or like this, or like this. But they all cross through the what? Point of origin. So we did some of those with a directrix in Y or directrix in X. From there, the following day, I said, you know what, guys, I'm going to crank it up a notch. And instead of working with these, now we're going to have the vertex be other than the point of origin, so that's why we give it HK. And we started using these, yes? For the past 2 days, I gave you 16 problems to practice, 8 every night. You guys were like, this is my favorite. So the first one was with directrix of y, and the other one with directrix of x. Okay, and we did some work and stuff like that. And this was a little bit elaborate because it has plenty of steps. Is that correct? However, for these past 2 days, which are the equations that we use for standard form? This one and this one. Yes? Now look up, please. The vertex is HK. So look at this equation, HK. But what do you notice? That what's left? The x and the y. The x and the y. Of course, p, but we'll figure out p later. But for right now, x and y. So look at the vertical parabola. Which one has the square, the x or the y? The x. So for parabolas that are vertical, the x always has the square. For parabolas that are horizontal, which one has the square now? The y. The y has the square. Okay? Now, we're going to need that for this lesson, and we're going to need your practice that you did by yourself. Copy that, please, on your Cornell notes. It says, example 3, write and graph the equation of the parabola in standard form, x squared minus 4x minus 4y plus 12 equals 0. Copy that, please. Yes, write the instructions at least for this one, because it's going to be the same instructions for the rest. Copy that. I'll give you some time. Okay, guys, focus, please. Everybody go like this. Bear with me, because this one requires a little bit more work than we've done on the previous ones. Please, pretty please. Now, to get started, I'm going to be asking some rhetorical questions. Let everybody know what that is. I'm going to ask a question that I don't need answers. It's for you to ponder and think about the next step. I'm just going to be cueing your noodle. You have all the information now. Now I'm just going to cue you to make sure that you get what we're going to do next. Ready? Okay, here we go. Write your utensils down. Look up to the screen. To get started, this needs to be in standard form. You're like, what does that mean, Mr. Q? Well, it needs to look like one of those. But it doesn't look at all like one of those. Okay, but we get a clue as to where to start. First clue. Which variable has the square? So that gives us a clue as to which equation we need to think about. We need to think about the x minus h squared equals to 4p parentheses y minus k. This is the standard form that we need to look at. And this one needs to look like this. But right now it does not. Second clue. What do we notice here? That the x is by itself and everything else is on the other side. Look at this. Tell your neighbor what we need to do to leave x by itself on one side. Get rid of the y and the constant. How? Add 4y and subtract 12. Add 4y and subtract 12. All right, let's see if that leaves us with x's on one side only. X squared minus 4x. And right now you're just paying attention. Check this out. Pay attention. I'm going to leave an empty space equals to 4y minus 12. Some of you are like, Mr. Q, why did you say you're leaving an empty space here? Talk it over to your neighbor, let them know what comes to mind when I say leave an empty space here. Everyone. Completing the square. That's why we've been doing those on the warm-up for the past 3 weeks. How do I complete the square? Add negative 4 over 2 squared, and whatever we do to one side, we do to the other. Right now, you're just paying attention. I'll give you time to copy. Focus, please. Therefore, I'm left with x squared minus 4x plus 4 equals to 4y minus 12 plus 4. Can I simplify this side a little bit more? Yes. That leaves me with x squared minus 4x plus 4 equals to 4y minus 8. And you're just paying attention. Goodness. And you're like, Mr. Q, it's getting close, but it doesn't quite look like it. However, check out your noodle, your big brains. Here we go. How can I make this look like this? Talk it over your neighbor. What can I do to this to make it look like that? That's true. Take the square root of the first and the third. That means x, 2, sine of the middle, squared. Oh, snap. Here we go. What is that called? That's called factoring. I factored this side. Now let me factor this side. Can I take the square root? No. But what does the word factor mean? To divide. What can I divide both terms by? 4, and I'm left with y minus 2. Does this look like this? Copy that, please. Bam! Let's go. Let me recap. To write a standard form equation from this, what was the first thing that we needed to think? Which variable has a square? The x. That made us think of our standard form equation. So I wrote x minus h squared plus 4p times y minus k. Okay? From there, to make it look like this, what did we find out? That all the x were on the... All right. Oh, so I said, we noticed that all the x values were on one side and everything else was on the other. So what did we do? We took the y and the constant and we moved them to the other side by doing the inverse. We were left with the x values. We left an empty space equal to the y values and the constant. Why did we leave the empty space? To complete the square. We did that to both sides, simplified, factored, and we end up with our standard form. Now, I'm going to write the standard form equation underneath to make sure it matches. X minus h squared equals to 4p times y minus k. Does it match? Yes. Mr. Q, why did you write it underneath? Because I want to make sure I can see clearly the vertex. What are the values for the vertex? H and k. Why do we need that, Mr. Q? Well, our colleague over here, Leo Bridge, I'm going to immortalize him in my YouTube channel. He asked, Mr. Q, how do we graph that? Good question. What do we need to graph, everyone? We need a focus. Write that down. What else do we need? A vertex. What else do we need? Directrix. What else do we need? Value of p. You're like, oh, yeah, let's go. All right, so at this point, I want you guys to stay focused because now it's going to feel kind of weird thinking it through, but it's going to look familiar because we already did this work going forward. Today, we're going backwards, yes. So yesterday and the day before, what was the last thing that we found? The vertex. Today, the first thing we're going to find is the vertex. Let's look at our equation. What is the value of h of the vertex? And the k value? 2. So our vertex is 2, 2. Does everybody see where we're getting that from? Yeah, that's why I wrote it there so it's clear. Number 2, the second thing that we found was p. How do we find the value of p? Look up, please, or you're going to miss it. Look up. Here we have 4, but on the original one is 4p. So I need these two to write an equation. 4p equals to what? 4, and I solve for p. Divide by 4, p equals 1. Copy that. You're like, oh, no. Right? Am I right or am I right? You see what I'm saying? So now check this out. Going back and thinking it through again. If it has an x squared, it's a parabola that's a vertical parabola. What does that mean, Mr. Q? That it opens up or it opens down. What does that mean, Mr. Q? What I need to know about that? That it has all 3 points lined up like so or like so. Is that correct? If that's true, if all 3 points are lined up like this, pay attention, straight up and down, what do all 3 points have in common? Think about it. The same x value. Same x value. If it goes straight up and down, it's the x value that it has the same. So what does that tell us about the folks in the directrix? That the x value is 2 and 2. All right. Now, yesterday, look up, for vertical ones, we didn't have this value. Remember? And we're like, I asked, how do we find that? Here it goes. I said, and I did that in green. To find this value, we did k plus p equal to whatever was here. Do we have a value there? No. But do we have k and p? Yes, what is k? 2. What is p? 1. So what goes in the little box? 3. So what goes there? 3. And last, check this out. This is a new formula or form. Look up. I'm missing this value, but it's going to roll off so easy. Check this out. If for this one I use k plus p, for this one I use k, that is correct, minus t. So therefore, 2 minus 1 is 1. That goes here. So that was my last number. Look up, look up, look up. This was the last number. What value is it of the directrix? The y. That's why our line is going to cross through y equals 1. Our directrix. Let's graph that. All right? So you have your graph paper. Get that in front of you. And me, I'm going to make my own. Start with the focus. The focus is 2, 3. So I go 1, 2, 1, 2, 3, and it's right there. What is the vertex? 2, 2, 2, 2. What is the directrix point? 2, 1, 2, 1. Do they all align? Yes. And through what value of y is the directrix going by? 1 of y, right here. So I sketch my line going through there. It's a straight line. And now, all we need to picture is our parabola. Does everybody picture the parabola going through the vertex? Away from the directrix, heading towards the focus. Just sketch your parabola right there. We don't need to do the computation for tonight, as long as you show me the direction of the parabola. Did it make sense? Yeah, right? Because we already did the work forward. Now it's going backwards. The only thing that was new or that we needed to put together is to make sure we wrote this in standard form. Okay? Let's do another one. We're going to do this next one together. Okay? Here we go. Example 3Q. Y squared plus 4x plus 8y plus 4. Y squared plus 4x plus 8y plus 4 equals 0. All right. So what is the first question that we asked? Which variable has the square? The y. So that should prompt your noodle to write parentheses y. And what follows for our standard form? Minus k squared equals 4p times x minus h. What does that mean, Mr. Q? That it needs to look like this. So what do you guys notice? That y is on one side and everything else on the other. So tell your neighbor what we need to do here to leave the y's by itself. Be wise about it. See what it did there? No? All right. Tough crowd. Everyone, what do we do? Minus 4x and minus 4. You do that to each side. Minus 4x minus 4. These cancel. We're left with y squared plus 8y. Leave an empty space equal to negative 4x minus 4. Why did we leave an empty space, everyone? To complete the square. So what do I add here, everyone? 8 over 2 squared, and whatever we do to one side, we do to the other side. Let's simplify. Y squared plus 8y plus 16 equals to negative 4x minus 4 plus 16. Can I simplify the right side a little bit more? Yes, Mr. Q. Y squared plus 8y plus 16 equals negative 4x plus 12. We're almost there. Look up really quick. How can we make this look like this? Tell your neighbor, please. Yes, square root of the first, square root of the third. Square root of the first is y, square root of the third is 4. Sign of the middle is a plus, right? That's squared. And what is that called? Factor. What can I factor for each term here? 2, yes. What's the greatest common factor? 4, but this one has a negative, so it's negative 4. So we're left with x minus 3. Does that look like that one? Where do we get 16? What is 8 divided by 2? 4 squared. Yes, so then we write our standard form underneath that to make sure we know all the values. Y minus k squared equals 4p, parentheses, x minus h. And why do we need that there? Because that's easier to see the vertex, which is h and k. Is that correct? All right. So, and then somebody asked me, how do we graph? Who asked me? Oh, Leo asked me. All right. So we need a what? A focus. We need a vertex. We need a directrix. And we need a value for p. All right. How are we doing? Okay. So let's see. Which is the easy one to find? The vertex. By matching these, I need first my value for h. What is h here? Now look up, please. That's why we align them, so you can look at the letter. H is 3, so that goes right there. So be careful. That's why I had you write it there. What is k? It's negative 4, because this is supposed to be a negative, so it's negative 4. So far, so good? All right. How do we find the value of p? So you box these, because these are aligned, and what do I write? 4p equal to negative 4 divided by 4. P equals negative 1. Bam, let's go. So, what kind of parabola do we have? A horizontal. That means it's going to open to the right or to the left. What does that mean, Mr. Q? That either we have 3 points aligned like this or 3 points aligned like this. What do all those 3 have in common if they're aligned like this? The y value. What is the y value now? Negative 4 and negative 4. Now, check this out. Be careful with your answer when I ask you right now. Look up to the screen. On this previous one, this was a vertical. What did all have in common? The x. And then I wrote k plus p. k minus p to find the last two pieces. Here it goes again. I had the x values the same, and then I wrote k plus p to find this one, k minus p to find this one. Think about it. Now I have all the y values the same. What would I write here and right here to find those two values? Tell your neighbor, please. That is correct. H plus p and h minus p. So, what is h? 3. What is p? Negative 1. So 3 plus negative 1, and that gives me 2. That goes right there. 3 minus negative 1. What is negative times a negative? Positive. Bless you. So this is 4, and that goes right there. So this was the last number that I wrote. This is the x value of the directrix. So what does that tell us? That our directrix line goes through x equals 4. Some of you are like, what's here, Mr. Q? Negative times a negative became a positive. All right, let's graph. Get your graph paper in front of you. Once again, plot your 3 points, your directrix, and then your parabola. Okay? There you go. And start with my focus. What is my focus? 2, negative 4. 1, 2, 1, 2, 3, 4. 2, negative 4 is right there. What's my vertex? The vertex is 3, negative 4. 1, 2, 3, negative 4 is right there. What's the directrix point? 4, negative 4. 1, 2, 3, 4, and negative 4 is right there. Do they all align? Yes. But which point is the line going to cross? X4, which is here. So I have my directrix line going through those 2 points. Hands, have you got that? All right. Our parabola graphs away from the directrix towards the focus, so it should look something like that. Piece of cake, yeah? Some of you famous how comfortable you are with this? Yeah, we did the practice already forward. Now backwards, it should be about the same. About the same. We just need practice, yes? All right? Let's see if you can do one by yourself. I'm going to give you a head start. And yeah, you can look at your notes, but try and go without looking at your notes as much as you can, and then look at your notes. Okay, here we go. Example 3 mega cube. Write this down. X squared plus 8x minus 16y minus 48 equals 0. Copy that and go. I'll give you a head start. Yep. Relax. All right. Let's see. What was the question that you asked? Which variable has a square? Everybody said x. That means we write x minus h squared equals 4p parentheses y minus k. Yes? What do we notice? That all the x's are on one side and everything else on the other. So what did we do here? We did plus 16y plus 48. Plus 16y plus 48. We end up with x squared plus 8x, empty space, equal to 16y plus 48. Hands are got up to right there. Okay? We complete the square. What do? 8 over 2 squared to each side. Add 8 over 2 squared to each side. Simplify. X squared plus 8x plus 16 equals 16y plus 48 plus 16. Can I simplify this side? Yes. X squared plus 8x plus 16 equals to 16y plus 64. Next, how can we make this look like this? Factor by square root of the first, square root of the third. X, 4, sine of the middle, squared. What is the common factor for these two? 16, and we're left with y plus 4. Hands, have you got that? Let's go. And of course the rest, you just need to find the points and graph it. Alright guys, there is tutoring today. It's free. If not, have a good one. Enjoy your home play. Make it a math family night. Bam! Thursday? Yeah. Have a good one, guys. See you guys tomorrow. Bye.